Hi, my name is Anil Palepu. I was advised by Dr. Andrew Beam, and I'm going to be talking to you today about my project, TIR, Text-Image Entropy Regularization for Medical clip-style models. So CLIP is a type of self-supervised model which is able to jointly represent paired image and text data. So essentially the goal during pre-training is to align the embeddings of both the text and image encoders such that true positive pairs are as similar as possible and negative pairs are as dissimilar as possible. So there's a lot of benefits to this. It's very convenient. We don't need any supervised labels, just the text, descriptions of them. It allows us to have a lot more details to these labels as well, so we can actually describe aspects such as the severity, the location of clinical findings, for example. We can use these to identify any kind of label that we can describe in language rather than having to choose beforehand what labels we're going to identify. And these models also can perform zero-shot classification, so we can actually perform this classification without training for a particular task. And we can actually, if we choose to, fine-tune these for those tasks after the fact, and often that will perform better than starting from a supervised model to begin with. So while this is all great, there are some issues, and one of these is that the clip-style models align the entire text representation with the entire image representation. And a problem with this is in medical imaging, it seems like a lot of the time the clinical findings are actually very localized in the image. So on the right, you can see all of these different findings take up between 5 to 20% of the image. So our goal here is we want to modify the CLIP pre-training objective to try to address this. And our solution was basically introducing a new regularization term that hopefully would help encourage these sparse representations. We ended up finding this to be successful. So our method led to both state-of-the-art performance as well as qualitatively a lot better representations for this chest X-ray interpretation. And so we penalize this models using this entropy regularization, the actual function you can see below. But essentially, you can see in these heat maps that if this is an example of an image with cardiomegaly, you can see that the region of interest is surrounded by this bounding box. And our unregularized model was very unfocused. It was assigning high similarities in the region of interest, but also very low similarities elsewhere in the image, which it really shouldn't have been paying attention to that at all. And here, our TIR model is a lot more focused and is really just sending high similarities in the relevant regions, which is what we would intend for it to do.